Hello everyone, welcome back to another episode of Under 10 Minutes. Today we will be talking about the intricacies of a system design process, the craft of transforming raw ideas into robust, scalable, high performing systems. Whether you're preparing for a high stakes tech interview or designing the architecture for your next breakthrough product, this episode is for you. We'll walk through each major phase, starting with gathering precise requirements to evaluating trade offs using structured decision frameworks. Along the way, we'll highlight industry tools and top tier cloud vendors that empower modern developers. Be sure to pause the slides to get deeper insights into each section. So let's get started. The first phase in the system design process is requirements gathering. Every system begins with clarity of purpose. Before a single line of code is written, ask yourself the fundamental questions. What exact problem are we solving? Who is the end user? What are the must have and nice to have features? Don't overlook the non functional requirements like responsiveness, throughput, security, and compliance. Documenting all this thoroughly helps keep everyone aligned. Tools like Jira, Confluence, or Trello become your digital blueprint, capturing user stories, technical needs, and design constraints in one collaborative workspace. Think of this step as lighting the path of all the architectural and engineering choices that follow. The next phase is architectural design. With solid requirements in place, the focus shifts to designing the blueprint of your system. Choosing the right architecture depends heavily on the complexity, scalability needs, and technical skill sets of your team. A monolithic architecture is like a cozy cabin, everything runs under one codebase and deployment unit. On the other hand, microservices architecture decomposes your system into independent services, each responsible for a specific domain. These services communicate over APIs and can be scaled or updated independently, giving your product a modular and resilient edge. Tools like Docker and Kubernetes can be helpful in deploying and managing containers for microservices architecture. Lastly, serverless architecture offers a dynamic, event driven model that abstracts away the server management altogether. Using cloud native services like AWS Lambda, Azure Functions, or Google Cloud Functions, you can write and deploy logic that automatically scales based on demand, perfect for unpredictable workloads but at the cost of some control. The next phase is scaling the system. Scaling is a very critical aspect that needs to be considered when designing a system. There are two types of scaling. First one is vertical scaling, adding more power like CPU, RAM to a single machine. It's fast but hits hardware limits quickly. The second one is horizontal scaling, which adds more machines to the pool, distributing load and improving fault tolerance. This model allows your system to continue operating smoothly even if individual servers fail. To control traffic flow, load balancers act as smart routers. Tools like AWS Elastic Load Balancer or Azure Application Gateway ensure each server gets just the right amount of traffic. Performance also relies heavily on caching. By storing frequently accessed data in memory with tools like Redis or Memcached, your system avoids unnecessary round trips to the database. Finally, cloud platforms like AWS, GCP, and Azure offer auto-scaling features that automatically adjust computing resources based on traffic, thereby ensuring high availability without overspending. The next phase is database design. Your database strategy determines how reliably and efficiently data flows through the system. When consistency and structure matter, like in finance or inventory tracking, SQL databases like MySQL, Oracle, or Microsoft SQL Server are your go to databases. They enforce schemas, asset compliance, and transactional integrity. Hosted versions like Amazon RDS or Google Cloud SQL make deployment and maintenance easier. For scenarios where flexibility, speed, and scale are more important, like product catalogs, user profiles, or social media feeds, NoSQL databases shine. MongoDB is great for documents, DynamoDB for key value storage, Cassandra for distributed white column data, and Neo4j for graph relationships. Make your decision wisely basing on the CAP theorem, which states that systems can only optimize for two properties from consistency, availability, and partition tolerance. Understanding these trade offs is key to designing a data layer that serves your specific needs. The next aspect in system design is performance and messaging. A great system doesn't just work, it responds instantly and gracefully. Latency reduction starts with content delivery. CDNs like Cloudflare, Akamai, or AWS CloudFront ensure static assets are served from the nearest geographic location. This dramatically improves load times. API efficiency also plays a big role. minimize the number of network calls, and avoid redundant data transfers to reduce perceived wait time. Now, when it comes to how services communicate, you have two messaging patterns. Synchronous messaging is like real time phone call, ideal for tasks that need immediate feedback using protocols like REST or gRPC. Meanwhile, asynchronous messaging decouples services so they can operate independently, perfect for background processing or time insensitive tasks. Message queues like Apache Kafka, RabbitMQ, Amazon SQS handle this beautifully, enabling reliability and scalability in distributed systems. The next one we have is security by design. Security is another crucial aspect of system design. Start with authentication and authorization. Make sure only the right users access your system using proven standards like OAuth 2 and JWT tokens. Next, protect data everywhere. Encrypt it at rest and in transit using SSL or TLS, and manage keys securely with tools like AWS KMS or Azure Key Vault. Then validate and sanitize all user inputs to guard against injection attacks or cross-site scripting. Tools like OWASP Zap automate vulnerability scanning and help tighten security further. Finally, establish continuous monitoring and auditing with tools like Splunk or Sentinel. System design is ultimately about strategic choice making, and every decision, a monolithic versus microservices approach, SQL versus NoSQL databases, synchronous versus asynchronous messaging, requires careful consideration of cost, complexity, and future scale. Think of it as building a decision tree. Revisit your original requirements at every branch and ask what's the best fit for our users, team, and roadmap. Should we invest in tight data consistency or prioritize system uptime and responsiveness? Does the need for rapid iteration outweigh the complexity of managing distributed services? Visualizing these paths using flowcharts or decision matrices can clarify trade offs and guide your team towards a design that not only works today but adapts to what's next. Let's take everything we've talked about and see how it all fits together with a ride sharing app that is used by millions of people every day. You open the app, request a ride, and off you go. But behind the scenes, there's a whole system working in real time to match riders with drivers, handle secure payments, and keep the experience smooth and reliable. In this slide, we've broken down the key design decisions that make all of that possible. You'll find the core building blocks, the tools or vendors you can use, and how each piece fits into the bigger picture. It's a great example to help you understand how real world applications come together. Make sure you check this slide carefully, it'll really level up your understanding of the system design. Whether you're targeting interview prep or designing production grade systems, these concepts and the tools behind them give you a roadmap to build scalable, secure, and elegant solutions. If this episode sparked a new idea or made system design feel more approachable, give it a like, subscribe, and share your thoughts below. Until next time, stay curious and keep learning. Bye bye.